Alright, as we get started, what you need to remember about slope. Okay, remember slope is the vertical change over horizontal change, or we call it rise over run. But more specifically, if you look down here, we have a formula. It's just the change in y, okay, over the change in x. So you typically call it y2 minus y1 over x2 minus x1. So just this little formula will come in handy as we're going through the lessons. But remember that slope, which is also in your packet under lesson 6.2 slope formula. Okay, so you're given that, so that's y2 minus y1. Now we're going to look at how we can just look at a line and tell if it's positive, negative, undefined, or zero. Alright, again we have our formula again. Now we're going to look here. Now positive slope goes from, you'll notice that it slants to the right, and we have our little penguin guy here going up this way, so this would be a positive slope. Lines slant uphill is the way we normally think about it. Okay, so that would be a positive slope. And then if you look down, we'll go down to the next one, negative slope if we're coming downhill. Okay, so that would be a negative slope. So again, we can look at a line and tell whether or not it's positive or negative by the way it tilts. So if you're not sure on a graph, or when you come up with the ordered pair, if you graph it, you could tell if it's positive or negative. And then we have a zero slope. If it's straight across our page, that's called, and you're not moving anywhere, that's going to be zero slope. Lines that are horizontal have a zero slope. Then finally we have no slope or slope undefined. So if it goes straight up and down, that's going to be undefined with this. So again, hopefully that helps to kind of jog your memory with this. Now again, we could come up with slope given 2 points, or given a line, we can come up with a slope. Alright, so what I want you to do is, again, this is from the one packet slope formula. It's the one that's page 7 out of 33. What I want you to do is you need to go through and tell if it's positive, negative, zero, undefined. Now on A, B, C, and D, and E, you need to be able to come up with the actual slope besides telling if it's positive. Okay, and we can do that by getting any 2 points off of it. So like, I'll work example 1 out here to prove that these two are parallel, and then you'll do the same process up here. Now in this specific example, we're actually supposed to prove that they're parallel. We'll do that, but we need to be able to come up with the actual slope first. What I would do is pick 2 points that intersect, that you're sure intersect on one of the diagrams. So I'm going to pick this point and this point. Now you can pick any point that lies on it exactly. So for that point, you go 1, 2, 3. So the x is 3, and then the y is up 1, 2, 3, 4, 5. So that point's 3, 5. Okay, and then the next point would be 1, 2, 3, 4, 5. So the x is 5, and then the y is 1, 2, 3, 4, 5, 6. Now you can do rise over run if you know how to count the boxes, which would give you the same answer. But I'm going to use the slope form equation. So I'm going to go y2 minus y1 over x2 minus x1. Now it really doesn't matter which one you call x1, y1, as long as you call the same points, the same x and the same y have to go together. So I'm going to go x1, y1, x2, y2. Alright, so it's going to be 6 minus 5 over 3. 3 has to go here. So the 3, they have to be in the same spot. And then the x2 here would be 5. Okay, and so then we go 6 minus 5, which gives us 1. 5 minus 3, which gives us 2. So our slope is 1/2, and it's positive. Again, it should be positive because of the way it tilts. Alright, so that was the slope of AB. Now let's figure out the slope of CD. I'm going to pick this point and this point. Alright, so I'm just going to count over, go 1, 2, 3, 4. So my X is 4, my Y is 0, because I didn't go up. And then I came down 1, well, let's just count over first. 1, 2, so I get 2, and I went down 1, so that's a -1. Now again, now last time, it doesn't matter which one we call x2, y2, so I'm going to call this one x2, y2, x1, y1. Sorry, that's got to be y2 because these have to go together. Alright, so let's find the slope of that line. So, slope of that one is going to be y2 minus y1 over x2 minus x1. Okay, so y2 is 0 minus -1. Okay, so we have to be careful to keep up with the signs here. And then we have x1, which is 2. Okay, and then we had x2, which would have been 4. Okay, so remember to change the signs here, double sign negatives. So that's 1. 4 minus 2 is 2. So that's how we find the slope given an equation of a line. Now, for these two, we just proved that these are parallel because they have the same slope. So remember, parallel lines have the same slope, okay, and they never intersect. So that means they have to have, and again, the up and down lines like that's usually how we represent parallel, but their slopes are equal. And then perpendicular lines, they have negative reciprocal slopes. So, and they intersect at a right angle.